To visualize truth tables, let's start with three basic Boolean operators, the ones we talked about before: and, or, and not. So in a truth table, we have a number of different columns and rows. On the left, we'll have a column for each variable in our statement, and on the right, we'll have a column representing the statement that we're interested in. The goal of the left is just to outline every possible combination of those variables. So if we have two variables with two options each, variable A and variable B, each of which can either be true or false, then we can have four possible combinations. They could both be true, both be false. A could be false and B could be true. A could be true and B could be false. Those are the only combinations we could have. Each of these combinations is going to provide values to that logical expression, which is going to give us answers to whether or not this expression is true. So in this case, our expression is A and B. Is it true that both A is true and B is true? Well, when we say it like that, it kind of becomes a little bit obvious. Is it true that both A is true and B is true? Well, if A is true and B is true, then yes, that's true. If B is false, then that's false. If A is false, then that's false. And if they're both false, that's certainly false. So that's the general way a truth table works. On the left, we have all the possible combinations of a couple variables. And on the right, we have the results of those variables put into a certain logical statement. We might actually have more than one of these if we're interested in comparing the results of multiple logical expressions. For another example, here's the truth table for the operator OR. Is it true that either A is true or B is true? Well, if they're both true, it's certainly true. If only A is true, then it's still true that either A is true or B is true. If only B is true, then again, it's true that either A is true or B is true. And it's only false if neither A is true nor B is true. And finally, our not can be even easier. Here we would only have one variable, and our expression would simply be not that variable. So we actually only need two rows. I've just included four by accident. So if B is true, then it's false that B is not true. If B is false, then it's true that B is not true. So here we can see that the not operator really just changes the value of B to the opposite of whatever it was. If this sounds a little strange, then think of it in terms of a real example. If it's true that grapes are rotten, then it's false that grapes are not rotten. If it's false that grapes are rotten, then it's true that they're not rotten.